So far, we have learned about memory management in the last lesson, and we are heading to another key concept of C++, smart pointer, custom smart pointers. So we will write our own class so that we don't have to use unique pointers, shared pointers, and so on. But sometimes it's useful to have that knowledge of smart pointers that you created, so custom pointers. And we will have that prompt here, and we're asking the Copilot to do the work for us. Let's try to generate our code again with this time with the GPT-4.1 instead of Sonnet 3.1, thinking of Claude model. Instead of that, GPT-4.1. Let's try that and how it performs. We can see that as well. And we have a smart pointer. We're asking to generate, demonstrate usage, add features, code expectation, various expectation, operator overloading, and so on. And our goal is to learn for the beginners. And let's enter our prompt. And it says it's working. Okay, we got something coming up with GPT-4.1, a smart pointer class, a person class, demonstrate custom smart pointer, unique pointer comparison, and there is main. So we have custom smart pointer and unique smart pointer. Those two with a smart pointer class. How these smart pointers classes look like and their uses. And let's see, let's execute the code and see how it performs. And we take custom smart pointer to our editor. Custom smart pointer to editor. And our editor is here. Apply to custom smart pointer CPP. Okay, new file, CPP custom smart pointer, and it has added to the editor. I will keep it. Let's hide the chat window and bring this window to balance so that we can see it properly. And we have our file, custom smart pointer. Let's compile. C++. It's a compiler. File name, output to custom smart pointer. There's an error. Warning, that's not an error. So what's the warning? Line number 141. 141 here. So it says address of SPD will always evaluate as true. So why is address SPC no longer owns the pointer, and SPD is a smart pointer, ownership transferred, and move Should this be SPD? I think so. Let's see. Compile. SPD is not contextually convertible to bool. Okay. Oh, that's an object. Yeah. Yeah, that's a class object. So we take the address of that. Okay, we'll go with that. And with the warning, and we have the file, the executable. Let's execute and see the result. So here we have on the top, and let's start with the main. Here is main demonstrates custom pointer, and we have custom pointer cout, custom pointer demonstration, that one. Then we have in this scope, we are creating an object of this smart pointer spint with new as initialized with 42, and data type is int because it's a template class. And then we will look into that smart pointers class. Template, whatever type we send is a T, that's what it comes as. In our case, it's an integer, so it will be int pointer, integer pointer, that means. And in the constructor, we have acquired ownership, the PTR in the constructor is called. There is a new pointer was sent. So this PTR will be pointing to that new. And in the destructor, if the pointer is a valid pointer, then it will be deleting. Otherwise, nothing to delete. That's what it says. And these are the operator overloaded for this purpose. This is the dereference, like star, operator is star, and it returns the address of the returns the dereference, that like the value of that, the PTR. And then this is using the pointer. It returns the pointer for that. And then we have a copy constructor. It just copies to that. So all that we see standard library like unique pointer, they are similar to this. They may have some more things. This is a custom pointer that we can have our own if we want to do something else or something different in addition to the smart pointers that what it provides. And this is the assignment operator and move constructor and move assignment operator. Here is a comment to be noted for safety. Disable the copy operation uncommon to prevent the double delete. So uncommon to prevent the double delete. So we want to the copy constructor and assignment operator, we want to remove that so that we don't want to have a double delete. In that case, in this case, it says dangerous leads to double delete. How is that? So what happens is in copy constructor, the pointer is copied to this pointer, like in another, from if two initialization happens, then this will be the pointer only it is copied. So whenever those two objects are going out of scope or deleted, so both of those objects will call the destructor, and because the pointer was valid, there will be double delete. So that is dangerous. So instead of this, we should be actually deleting this uncomment this. So if we uncomment um, function, oops. So this, if we uncomment, and this one we should comment, that time it will be correct. And then there's a person class. It has a person name, constructor, destructor, and greeting. Hello, Mr. Someone. And the custom smart pointer. Let's see now what was happening. So custom pointer, we have the object, uh, the pointer is created, and then we, using that operator, overloaded operator, we initialize a value 100, and here's the initial value and the new value 100. And in this scope, managing the user-defined object, a person, we saw that person is created, Alice, smart pointer. Oh, this is in the scope. So the structure is called when it is going out of this place. So the memory is deallocated here, deleting this. And other object is person, smart pointer with person, and the greeting is happening, and using this also you are greeting. Greeting, hello, my name is Alice, my name is Alice, twice. And when it is going out of scope, same thing, the deleting um, that memory, and also the person, this is the new, that also is removed, that destructor of that person is called. And demonstrating double delete problem. So we saw that double delete, how it is failing. Both destructor will call delete for the same pointer. So here is what we have. SPA is a new with int. It has a memory address, and SPB assigned with SPA, and SPB also has the same memory address because it is assigned. Now both of these go out of scope, and okay, their values are also displayed here, the pointer and the values. The pointers are in the constructor, copy constructor, where it is displayed, and values are same. The destructor of these and deleting this as well. So it's happening twice, and that's a problem. It will actually fail. Uncomment the following line in the smart pointer to disable the copy constructor. So we need to disable the copy constructor so that uh, the copy doesn't happen. This doesn't happen. This should fail. We cannot do that. And copy constructor and assignment operators. So that was in the file we in the class we have seen. So here is another option. It is showing after disabling the copy constructor. Okay, after disabling the copy constructor, we will have this. So we cannot assign, but we can move that SPC to SPD. And when SPD is a valid, and then is you print this SPD is here. SPBD double free of the object. Malloc. Okay, so this program is actually failing because of this double free. Here we have. So this is exactly the error it is talking about. And so we have to, in order to demonstrate this successfully, there's abort is happening, meaning it's failing. We cannot have double delete. So a smart pointer and any pointers, when we try to do a double delete, then it will fail. So now to correct that, we have this here. And we have uncommented these for safety, and we cannot have both of these, so we need to have comment this, and then move. This move will work as we see, and in this place, this should be commented. So here is already the IDE is detecting that you cannot initialize this. This will be a compilation error. So it's telling that this function blah 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 is deleted. So you cannot have initialize like this. So we will have to comment this, and now it is fine, and this will work. And we will come back and we will run again and see. So demonstrate unique pointer comparison is we will see, because it failed earlier, it did not execute. So now if we compile again, we are compiling again, and it still has the warning, but we'll run again. This time it went all the way to the end. So we see that this one, SPD, SPD has a value. So because there is no issue now, the SPC and SPD, though it is going out of scope, SPC is already moved. Moved means ownership is transferred. So it is already cleared. So it did not fail at this place. And after that, we have other function. This one has it is using the unique pointer. Unique pointer person1 and person2, even though it is here it is moved. So because ownership is moved, it's the same thing as it did. The Bob person, the name Bob constructor is called. My name is Bob. It is twice created, this one and this one. And the destructor of Bob is called destructor. Even after moving person2, it goes out of scope, and person is destroyed. This one is the person object is destroyed. This one, Bob. So that's about the pointer. This is the custom class smart pointer, and it behaves similar to unique pointer. And initially there was some error that it generated so that we can demonstrate what it means. So earlier it was an abort, it failed there. Here in this function here, because there is a double delete. And that's about the custom pointer, smart pointer. And there are much more we can do with this concept. And with that, we will go to the next one, even advanced concept. We have advanced topics of C++, and I will see you in the next lesson. Thank you.